Yesterday, at 7:33 a.m. local time in the Philippines, the Kanlaon Volcano produced one of its larger eruptions. Now, I know that this view is obscured, but you can still make out the gray rising ash plume. This eruption plume subsequently rose to an altitude of 4,922 meters or 16,148 feet, drifting to the east. As this was occurring, a pyroclastic flow descended the southeastern portion of Kanlaon's summit, seemingly staying within a kilometer of the eruption site. Now, quickly listen to the sound of what I interpret as a secondary explosion and falling lava bombs and tephra that were ejected. Before I discuss the scientific specifics of this eruption, you might be wondering why, unlike essentially every other of the 8 larger eruptions Kanlaon has produced since June 2024, that the camera view is so heavily obscured. To answer this, all we need to do is zoom out. Partly clear skies on July 7th became completely overcast on July 9th as the very edge of Super Typhoon Bavi impacted the Philippines. Thus, there was honestly no chance that we'd ever get long-term visibility at the volcano yesterday due to a more than 1,000-kilometer-wide storm. Due to eastward winds, limited ashfall even ended up reaching parts of Cebu Island and Mactan Island, which in the case of the Mactan-Cebu airport caused some flight cancellations. But why did this eruption occur in the first place? After all, the morning July 9th eruption was by some measurements the strongest single eruptive event the Kanlaon volcano has produced in 4.5 months. While some of the prior larger eruptions at Kanlaon were caused by a plug forming in its main vent that essentially blocked all of its volatiles for a time, causing pressure to build up before finally clearing, it seems to me like something different occurred in this case. Looking at the recent geophysical data, the number of daily volcanic earthquakes and amount of sulfur dioxide emissions nearly doubled in the prior 48 hours. This suggests to me that a temporary increased magma supply occurred, and that some of this could have gone stuck behind a narrower segment of the magma conduit. Thus, while some intermittent smaller eruptions occurred in the prior few days, increased earthquakes were triggered due to the different type of plug that did not trap all of the degassing sulfur dioxide, leading to observations on the surface of increased sulfur dioxide emissions. So yes, I suspect that this eruption was somewhat magmatic and not purely phreatic. The Kanlaon volcano, for reference, has been intermittently erupting since it produced a powerful explosion on June 3, 2024. Activity then further changed in October 2024, and since then it has mostly consisted of intermittent weak ash emissions that can last for minutes to hours that rise no more than 1,000 meters above its towering summit crater. Some larger eruptions like we just observed can also happen, but only 9 of these have taken place in a 25-month time span, occurring between 7 and 189 days apart so far. While pyroclastic flows from these larger eruptions have on multiple occasions traveled more than 2 or even 3 kilometers downslope, none of these have thankfully gone beyond the volcano's current 4-kilometer exclusion zone that surrounds Kanlaon's summit in all directions. While it is possible that another similarly large eruption could follow in the next few days to weeks, I honestly don't have enough data currently to make that assessment whether or not that might happen. What is, however, statistically most likely are that more smaller low-intensity ash emissions like this in the following days to weeks might occur. After all, in the 30 days preceding the July 9th eruption, Kanlaon produced 55 such weaker ash emissions. As a final note, I would like to thank my new YouTube channel member Aeronautics Audio for supporting my work.